titled Union, Intersections, and Complements. So today we're going to look at page 12 and page 9. And then on the next day we're going to look at pages 10 and 11. So we're going to answer the question, what are the chances of both events? So let's first turn to page 12. So turn your packet to page 12. Page 12 is our math notes page. If you have a highlighter, great. If you don't, you can just circle the keywords that we're going to talk about. When considering two or more probabilistic situations with outcomes that are not all equally likely, a tree diagram or area model can be used to calculate probabilities of compound events. Suppose you spin the two spinners shown to the right with the probability shown in the table below. So we saw this spinner the other day, right? Spinner number 1 gave us I, U, and A. Spinner number 2 gave us T and F. And we had to see if we could make a word out of it. There's even the Desmos e-tool that you can go in and click the spinner for you. So this is what's called a probability area model. It is practical if there are exactly two probabilistic situations and they are independent. Independent means they don't rely on each other. Okay? Spinner number 1 does not rely on spinner number 2, and spinner number 2 does not rely on spinner number 1. In this type of model, the situation is represented by the square with an area of 1. So that the areas of the parts are the probabilities of the different events that occur. The outcomes of one probabilistic situation are across the top of the table, and the outcomes of the other are on the left. For example, the probability of spinning UT is 1/6 times 1/4, which is 1/24. Okay? Then at the bottom we have the tree diagram. So a tree diagram can be used for two or more probabilistic situations. In this model, the ends of the branches indicate outcomes of probabilistic situations, and the branches show the probability for each outcome. For example, in the tree diagram at right, the first branching point represents spinner number 1 with outcomes I, A, and U. So here's I, here's A, here's U. The number on each branch gives the probability that the letter occurs. So I is 1/2, A is 1/3, and U is 1/6. The numbers at the far right, somebody needs to turn their phone off. The numbers at the far right of the tree diagram represent the probabilities of various events. For example, the probability of spinning U and T can be found at the end of the bold branch of the tree. We go U, then T, we get to 1/24. Can be found by multiplying the fractions that appear on the bold branches. So if you take the 1/4 times the 1/6, you're going to get 1/24. All right. Now you're going to flip back to page 9. Back over to page 9. Question number 35 says, Election day is less than a month away, and political analysis are focused on the races for two statewide political offices. According to a recent poll, in the race for governor, 40% of voters support the Republican candidate, and 53% of voters support the Democratic candidate. In the race for attorney general, 61% of voters support the Republican candidate, and 37% of the voters support the Democrat. Assume that voter preference of candidate for each of the two offices is independent of each other. So if somebody votes for the governor for Republican, they're not necessarily going to vote for the Attorney General for Republican. They might vote Democrat, or what we're going to see as other. Okay? You hear a lot about Republican and Democrat, but there are other political parties, and there are other political candidates. Okay? If you notice, 40 plus 53 adds up to what? What's 40% plus 53%? 93%. So how much other are there people voting for other candidates? 7%. There's 7% voting for someone other than a Republican or a Democrat. Okay? All right. So for question A, it says, what is the probability that a randomly selected voter supports both a Democratic candidate for governor and the Democratic candidate for Attorney General? Okay? So first we need to take the percent for Democrat for governor. So I did that one in orange, which was 53%. 53% as a decimal is 0.53. Then I did 37% for the Democrat for Attorney General. 37% as a decimal is 0.37. You're going to take your calculator and multiply 0.53 times 0.37. You're going to get approximately, notice I use the wavy equal sign because there's a bunch of decimals across my calculator, 0.196, which if you multiply that by 100, you're going to get 19.6%. Any questions on part A? All right. Part B says, what is the sample space for all the possible outcomes in voter support of the candidate for governor and Attorney General? Okay? So R is for Republican, D is for Democrat, and O is going to be other. Okay? So for governor, they could vote Republican and Attorney General Republican. Or they could do Republican then Democrat. Or they could do Republican and other. Or they could vote Democrat and Republican, Democrat and Democrat, or Democrat and other. Or they could vote other and Republican, other and Democrat, or other and other. So the sample space gives you all the options of how a person could vote. Any questions on part B? Okay. Move it up so you can still see it if you're still writing. Right there. Okay. Part C says a set of outcomes or a subset of the sample space is called an event. Which outcomes from the sample space are in the event supporting Democratic governor? So I did that one first. That's the top line. So it could be Democrat, 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 Republican, and Democrat, other. And then which outcomes are in the event supporting Democrat, Attorney General? Democrat, Democrat, Republican, Democrat, or other Democrat? That's for Attorney General. GOV is just short for governor. AG is short for Attorney General. Okay? Any questions on part C? Okay, awesome. Part D says the intersection of two events, A and B, is the event consisting of all outcomes that are in both A and B. If you have not done so already, create an area model for this situation. What outcomes are in the intersection of the events, Democratic governor and Democratic Attorney General? How can this be seen in the area model? So they didn't give much space for the area model here, so I drew it below. in the lower right-hand corner where there was more space. Okay? So across the top, I listed the choices for governor. Republican, 40%, Democrat, 53%, other, 7%. And then along the side, I did Attorney General. Republican, 61%, Democrat, 37%, other, 2%. Then to fill in the area model, each box gets multiplied above and to the left. So for this box, you multiply 40% times 61%, and then write your decimal. Same thing here, above and to the side, fill it in. Above and to the side, fill it in. You do that every time to fill in the complete area model. All right? What outcomes are in the intersection of Democratic governor and Democratic attorney general? So here's Democratic governor. I highlighted them all in yellow. And then this row is for Democrat attorney general. I highlighted them all in orange. And what you'll see is the intersection. Right here in the middle, the middle box is highlighted yellow and highlighted orange. It's the intersection of Democrat for governor and Democrat for attorney general. That's why we list DD is the intersection. Part E says, shade your area model to highlight the event Democratic governor, so I did yellow. Then shade your area model to highlight the event Democratic attorney general, I did that one in orange. What do you notice about the intersection of the events? The intersection is shaded twice, okay? Yellow and orange. So if you have two colored pencils or two different color highlighters, you would highlight them two different colors.